Okay, so let's start. In this lecture, we discuss Perl. Perl is a scripting language that makes manipulation of text, files, and processes easy. So it is a cross between shell programming and C programming language. So we learn shell programming. In the previous lectures, we mainly focused on the board shell, but other shells are mostly the same, but with some slight differences. Its main strength of shell programming is manipulating text. That is, you can manipulate strings very effectively, but not for numbers. Right? We learned we cannot even do floating point arithmetic. It could only do a simple integer arithmetic. C is very good at numbers. It's really a general purpose language. It's good at pretty much everything. So Perl is a mixture where it's more expressive than shell programming, than board shell. But it's less expressive than C, so it is good at both numbers and text. So C is really the most powerful language. So anything Perl can do, C can also do. But Perl can do some things very succinctly. That is, you can write a line of Perl program which may translate into hundreds of lines of C code. So Perl is powerful and very succinct compared to C. We'll learn later. So Smalltalk is an object-oriented language. It predates Java and C++. It's the most one of the earliest object-oriented programming languages proposed. And it's very pure. So if you do 1 + 1 in Smalltalk, it's really you're sending a message to an object which contains an attribute with value 1. So everything is, even simple arithmetic, are translated into object-oriented concepts. For that reason, Smalltalk is very inefficient when you're doing arithmetic because it's too pure. Everything is an object. Even a simple 1 is an object. So C++ is a mixture of C and Smalltalk. That is, for larger objects, say student, class, you may have attributes like student ID, age, CPA, etc. That's an object. But for simple numbers like 1, 2, and 3, they're really numbers. They're not turned into objects. So it's not purely object-oriented anymore, but it's much more efficient. So, and finally, Java is, you can view it as C minus minus. It removes some features of C++ to make programming less error-prone. So Perl provides a more concise and readable way to do many tasks compared to C++ and the shell scripts. It has replaced shell programming as the most popular programming language for text processing and Unix system administration. So text processing means that perhaps you take a body of text, you want to manipulate the text by parsing it and changing it somehow. And Unix system administration uses Perl to write many Unix scripts for managing systems. So if you look into a Unix system bin binary directory, you may see many files named with the suffix pl. So that's Perl scripts. So it was originally designed under Unix, but now it can run under all operating systems. It's also a popular language for CGI and the graphical user interface programming. CGI is a web programming paradigm where you can invoke a server on the web server. So we'll discuss CGI later. So Perl, if you type in PRL, it invokes Perl 5.0. Some systems may use 4.0 as the default, but you can use you can explicitly invoke Perl 5 with Perl 5. So you can run the script directly if you make the script executable. That is, you do a chmod. You do a chmod plus X. This means that gives the user, the owner, executable rights to the script. A chmod plus X is equivalent to chmod U plus X. You can omit the U. And then here's the simple script. It's actually too simple. It has an empty body. The first line is pound, exclamation mark, and the path to the Perl 5 executable, and dash W. So this is the first line, similar to when you write shell scripts, you say pound, exclamation mark, user sh, user bin sh. So it's similar in that you specify Perl 5 as the interpreter to process this script. And dash W means that you print out more error messages. If you don't have the dash W, then it prints out less error messages. So if you're doing debugging, it's a good idea to have dash W. And this line must start from the first column at the first line. So it starts with a pound, so it looks like a comment, but it's not. Because it starts with a pound exclamation mark, it's a special comment that is read by the script to understand which executable to invoke, to interpret the script. So dash W means produce extra warning messages about potential dangers. So use it in all your Perl programs. White space doesn't matter in Perl. Except for the first line, which must start from the column 1 on line 1. So all Perl statements end in a semicolon, like C++. Comments begin with a pound, like shell scripts. Everything after the pound to the end of the line is ignored as comments. Pound need not be at the beginning of the line, so you can start in the middle of the line, so anything after the pound are treated as comments, while anything before the pound is treated as regular program. There are no C++-like multi-line comments like this. So if you want to do multi-line comments, you have to type in many counts. Here's a very simple L04 program. So you can see that it's executable. You have X in the user's permission bits. So it starts with this line. So you specify you use this Perl 5 under user local bin, and have a comment, and have a print. So when you invoke it, it uses Perl 5 to interpret this script and prints out hello world. So you can also omit the first line and write Perl 5 hello and explicitly invoke Perl 5. So print sends the string to the screen, and \n adds a new line, just like in C programming. Parentheses are optional, so you can add it or not add it. Or you can write it in the C++ function style. So print is like a function where there's no space between the print and left parentheses. So, but it's not the same. It looks like the printf in C, right? But it's less powerful because you cannot do printf, say, $D and the integer. You cannot do that. You can only print out a string. A scalar variable can hold a single number or string, like shell variables, including integers and floating point numbers. So this is the difference from the shell programming we learned last class, where you cannot express floating point numbers. So shell variables begin with $, followed by a letter, and possibly more letters, digits, or underscores. So all these are legal scalar variable names, and they're case sensitive. So large a and small n are different. Scalars are assigned using equals. So scalar equals expression. Expression may be an integer, a floating point number, or a string. So say number equals 25, and $name equals Bill Gates. So unlike shell scripts, use the $sign both when the variable is used and assigned. So look at this script. Number equals 25, name equals Bill Gates. Print number name. So you print out 25, Bill Gates. So if it's a shell script, then we are assigning the number and name should omit the $. And when you print it, you should add the $, right? But for shell scripts, you add $, at all times. And also, this language Perl is untyped. That is, you do not need to declare a variable as integer or string or floating point like in C. You just use it. You can assign it to a different value at any time. So all numerical scalar values are stored as floats internally. So you don't have to worry about integer division in Perl as like you do in C++. Say if you have 5 divided by 3, if you simply do assign it to an integer in C++, then you get 1. The rest of the 1.667 are the fractional parts are thrown out in C++. But in Perl, every numerical scalar value is automatically stored as floats. So you automatically get 1.667 in Perl. Always. So because you don't have variable type declarations, every numerical scalar variable is floating point. So even if it's an integer, it's stored as say 25.0000. So here's a equals 25. You can say plus equal 5, then it's 30. Times equal 3, then it's 90. Plus plus is 91. Minus minus is 90. Result is and then 90 plus 2 times 3.4. You get floating point number 312.8. So for input, you can use the stdin, standard input. This means from the keyboard, from the user. So you print out a prompt, enter name, and then this line has the effect of waiting for you to enter something and pause it at this point. and you do a chomp. Chomp is an operator to remove the trailing new line. So we'll discuss next. And then print out another prompt, how many girlfriends do you have? Then read in a number, and then chomp, and then say something has something girlfriends. So enter name, you enter Bill Gates. How many girlfriends do you have? You enter more than you. And then it prints out. So you can see that it's untyped, right? You would expect if you input a number, you should input, say, 3 or 5. But the Perl doesn't care. You can enter a string, more than you. So it prints out more than you. So std line grabs one line of input, including the std in, including the new line character. So after this guy, if you type in Bill Gates enter, it will contain Bill Gates plus the new line. So to delete the new line, the chomp function takes a scalar variable and removes the trailing new line if present. If there's no new line, then it does nothing. So it's always safe to use chomp. You can use it multiple times. It wouldn't cause any error. So a shortcut to do both in one operation is just to do chomp parentheses and then input. So if you really want to print out the dollar sign, you put a slash dollar. Slash is an escape character. Anything after the backslash is treated literally without any interpretation. So have a backslash here. So this guy is treated. It printed out as a literal dollar sign. The next dollar is combined with the cost to indicate a scalar variable. So enter amount, so you enter a 18.5, and then total is 18.5. So here we didn't use chomp because the new line on cost, it can be used when it's printed. So we actually want to print out 18.5 plus a new line. So we didn't use chomp here. If we did use, yes?
If I type in a full number, like here 18.5, we did count also a new line in it. Because it's a number, not a string here.
Yes, because when you enter 18.5, you type in enter. That's a new line.
Yeah, but will the Perl treat it as a number or a string?
Perl knows it's a number. So unlike in shell script where everything is a string, only when you do a backslash expression, then you know it's a number, treat it as a number. In Perl, when you enter a number, it knows it's a number. So
the new line will still here, although it's a number.
Yes. Yes, it's the new line is there. Backslash n. I think when you do arithmetic, if you don't do chomp, you can still you can still do arithmetic on it. You can add and subtract from it. Yeah. Here's another example. Right, that answers your question. So enter height of the rectangle. You enter a height, enter a width, and you do area equals height times width. So if it's 10.5, they get 50 as the area. And if it's 10.1, 5.1, it do 51.51 as the area. So we didn't do a chomp here, right? It means that it looks. So it means that the backslash n, the new line at the end of the number, doesn't matter really when you do arithmetic. But of course, if you enter, say, enter height of the rectangle, you enter Bill Gates, then it'll assign Bill Gates to height. Then everything will be fine until this line. When you do arithmetic, it'll detect, okay, it's not a number. So you can do a command substitution. So say, who am I? This is the shell script, shell command to print out the current logged in username. If you surround it in backwards, it means that execute this command and put the output into the user scalar variable. So of course, if you do a double quotes, then it assigns the literal string "who am I" to user. But if you do a backward, it actually executes the command before sending the output to the user variable. So who am I? So suppose the current user who logged in is Gates. You assign Gates to the user. You chunk, remove the trailing new line, and then you do a num. So it is the who piped with the output piped to word count -L. That is counting how many lines in the output of who. So this counts the number of user sessions currently active, because each user session occupies one line in the output of who. And then remove the new line and say, hi, Gates, there are how many users logged on? 6 users. So command substitution will usually include the new line. So who am I? The output is really Gates new line. So you should do a chunk to make the output of test 7 look prettier. So Perl has a control flow, just like in C, if while for unless until, do while do until for each. So if works almost the same as in C++. So you enter a user and then chunk it. If user equal Gates, print hi Bill. EQ operator compares two strings and returns true if they're equal. If you have numeric numbers comparison, you use the double equal sign. So there's no such equivalent operator in C++, right? You cannot compare two strings for equivalency unless you use a function. So curly braces are always required in Perl, like this, these curly braces. Well, in C++, you can omit the curly braces if you only have a single line in the body. It avoids the dangling else problem. Dangling else is when you have, say, 2 lines, print and some other line, and then have the else. If you forgot the curly braces in the first part of the if, then the next else is dangling. It doesn't know which if it corresponds to. Especially if you have multiple ifs nested. So by forcing you to have curly braces, it's actually good programming practice anyway, even in C++. So it avoids the kind of ambiguities. So if else is similar, if user equal Gates, print hi Bill, else print hi user. You can have a list of cases, if, else. So now this users now contains a number of users, so it's a number. So the comparison now is numeric comparisons. So you use greater than or double equal if you want to test for equality. Greater than 4, heavy load, greater than 1, medium load, else just me. So again, you see the untyped nature of the language. Users can contain the username or can contain the number of users. So numeric comparisons are these, and string comparisons are these. So they're different because the internal algorithms of comparison are very different. So when string, what does it mean for one string to be less than the other string? It's alphabetical. So A is less than B. And if it's a string, then you compare first character, and if they're equal, you compare the next one until you hit one that's not equal, and then you can say less than or greater than. Choose what expressions evaluate to false. So traditional, think about in C, anything that evaluates to 0 is false. If you have an if expression, if the expression evaluates to 0, it's a false. Anything that other than 0 is a true. So here, 0 and null string and non-zero string, non-zero length string with a single character 0 is also treated as a false. So notice the difference between this guy and this guy. So the first one is a numeric 0. Second one is a string with a 0 in it. So if it's in C, then the second one, the string will be treated as a true. But here we treat it, Perl treats these two as equivalent. They are both viewed as false. So traditional truth value 1 is a true. Any non-zero numeric value is true. White space is true. Strings are true. And this guy, 00 in the string, is also true. So we can do combinations, just like in C, and, or, and not. So user, who am I? That's the username. Not me is this number me. That is number of my login sessions. So who output pipe to grep user. That is, pick out the lines containing the my username, and then count how many lines there are. So this counts the number of login sessions by me. And end users counts the total number of users, including me and anybody else. So if non-end users minus number of me, it means that there are more users more user login sessions than my session. So it means that someone else is logged in. So else, if number of user sessions is the same as number of my login sessions, then all is well. I'm the only one logged in. Notice that it says and user not equal to Gates. So it's really a joke played on Bill Gates. It says if the user is not Gates and he sees someone else logged in, you say someone else is logged in. But if the user is Gates, then he says all is well, even though someone else is logged in. So it's evil, right? He hides some information. So even though someone else is logged in, I don't tell anyone if I'm Gates. So while loops indefinitely, while the condition is true, so response is a string. It's assigned no initially. While response not equal to yes, then you ask wake up, and this takes in an input string and chomps it. So and returns to the top of the while loop. So initially, response is equal to no, so the while you go into the while loop, and you type in the no, it comes back to the top and compares it to yes. It's not equal to yes. So it comes back and type in y is not equal to yes, and finally you type in yes. Then the condition becomes false, and you jump out the while loop. For, just like in C++, you enter a number, and for I equal 1, I less than n, less than equal to n, I plus plus. In fact, this is just exactly like C. The factorial of n is fact. And here, you didn't do a chunk, right? Therefore, when you enter the stdin 5 into it, you actually have 5 new line. So when you print it out, you have a 5 new lines. The next line, you start the is 120 at the next line. So if you do a chunk, then you can print this line in a single line. So if you do a chunk stdin, then it's a single line. So last command works like the break in C++, breaks out the innermost loop. So here, while 1, it loops forever, and you say if response equal to yes, then last. It means go to the last line of the while loop. That is, it goes to here and exits. So it's the same program like in the previous while loop example. So concatenation with the dot operator. So name equals Bill.Clinton. It means I concatenate Bill and Clinton into a single string. You can directly print concatenated strings with the dot, and so you print Bill Clinton and Bill Gates. Notice that there's no empty space in between. Through repetition, that operator allows you to repeat a string several times. So name equals Bill times 3. So when you have star, it means that multiply numerically. When you have x, it means that repeat a string multiple times. So now name contains Bill, Bill, Bill. Bill repeated 3 times. So n equals 4. So now you print out Bill times 2, Bill, Bill. Gates times Gates xn. That is Gates repeated 4 times, 4 Gates, and finally a new line. And then you print out a single number 5. You print out n plus 1 x 4. It means that so n plus 1 is equal to 5, and then 5 repeated 4 times. You got 5, 5, 5, 5. If you say n plus 1 star 4, then it gives you 20. Also notice that you can treat this 5555 as a number. You can say test plus plus, it gives you 5556. So Perl automatically treats any numeric number as numeric values. So putting variables inside double quotes is called variable interpolation. So name would be the longest possible variable name that makes sense at that part of the string. So Bill equals to trouble. Bill Gates is another scalar variable. whose value is assigned cheap. So bill is trouble. The first line prints out bill is trouble. Second line prints out bill is dollar Bill Gates. So bill is cheap. So this guy, you do a longest match. That is, even though dollar bill matches the string variable bill, because you then you look for the longest match, then you match the Bill Gates variable, not the bill variable. So you produce cheap. If you want to override this, you want to match bill, dollar bill, you force it by placing curly braces. Then bill is value of dollar bill trouble followed by the literal string Gates. And of course you can do a dot to concatenate two strings instead of bill is dollar bill. You can see bill is parentheses dollar bill dot both bill. So it's these two lines are the same. These two lines. And finally, you can use dot to connect to the new line string to the rest of the string. So these three lines are equivalent. So exponentiation operator, you have n equals 2, n equals 3. The result is equal to 2 to the third power. That is 8. So C++ doesn't have this operator. Operator precedence is the same as C++, that is multiply and divide have higher precedence than plus and minus. So n plus 1 times $m, it means that 2 plus 1 times 3 equals 2 plus 3 equals 5. If you see parentheses, then you get 2 plus 1 parentheses times 3, which is 9. So these lectures are quite simple, so we will move on to the next part. So lists. I think we'll go over the quiz a little bit. So it's really very simple syntax issues. So what's wrong with this program? $pound something. So this is supposed to be a Perl script. So you shouldn't have, this is for shell script. So you should have the first line as pound dollar user bin per 5, etc. And also, in Perl script, we use a variable either for assignment or read its value. You always have a dollar sign. So you should add a dollar in front of the name and number. Use dollar name in DDE and dollar number in stdin. And finally, new line should be inside of the quotes. To revise is this. So it's so this guy. What's wrong with this program? First, you see that there's no semicolon at the end of the lines. You should have semicolon on all these lines, except the first line. So the first line, you should start with from column 1. Notice that it's special. Empty spaces, white spaces generally do not matter in Perl, except on the first line. So it shouldn't be a space here. And echo is a shell command. In Perl, you use print. And also, when you print something, it's better to place a new line at the end. So for this guy, username equals who am I. You should use back quotes. Back quotes means evaluation of the command. You execute who am I and place the output into username. Single quote and double quotes would all quote the literal string who am I into username, which is not what you want. And you should chump it to remove the new line. Otherwise, you have a new line in front of the exclamation mark. Double quotes on line 3, when you do print, use double quotes. And it should be user local bin per 5. It depends on your system. For our system, it's in user local bin. You should specify the actual path name to the per 5 executable interpreter. And also, username is illegal variable name. You should not have a dash in a variable name. So just very simple syntax issues. So lists. So we discussed scalar variables in Perl just now. So now we turn into list variables. So list is an ordered collection of scalar data. So it's different from a set, right? A set is unordered. So a list is ordered. That is the order. Different orders leads to different lists. Begins and ends with parentheses with elements separated by commas. So this guy is a list with 4 entries, 4 elements, 1, 2, 3, and 4.1. You can have a mixture of numbers and strings inside of the list. So you can say Bill 4 pi B Gates as a single list. So this guy is num 17, num plus 1 plus I. You can have expression as an element. So at runtime, it evaluates the expression and place the numeric result as the list element. Memory for list is dynamically allocated and removed as the program runs. So you don't have to worry about the memory allocation. This is just like Java, right? You do an automatic garbage collection. While in C or C++, you need to do malloc or new to allocate the memory. Empty list is a parenthesis surrounding empty space. List constructor dot dot creates a list of values with increments of 1. 1 dot dot 4, same as 1, 2, 3, 4. Of course, you can have white space or no white space around the dot dot. They're equivalent. So 1.2 dot dot 5.7. So the first dot indicates a floating point number 1.2. Second dot indicates 5.7. And intermediate dots means that take the integer values with increments of 1 in between these two values. So it turns into 1, 2, 3, 4, 5. So this is a little bit unexpected. That is, you start with a 1, you throw out the point 2 fractional part, and you count up to 5. So 1 comma 5 dot 7, same as 1, 5, 6, 7. This guy depends on the values of min and max at runtime. This guy, same as empty list, you cannot count down. So if you have the first element larger than the last one, then it's empty list. So this is a list. Bill Gates pie toss with 4 single word strings. You can do a quote word, parentheses like this, and then it'll be equivalent to the above string. Also, you can have new lines in the middle, and it still be equivalent. So this came from an incident where Bill Gates was giving a lecture, and someone placed a pie in his face. If you recall this incident in, I think it's in Netherlands. So array contains a list with 0 or more scalar values. So array variable names are similar to scalar variable names, except the initial character is @. So this guy, numbers array with the @ in front of it, contains the list. This guy. So we say array when we talk about variables. We say list when we talk about the actual list. So they're really the same. So you assign all equals to numbers. So you copy the numbers array to all. Here you see the automatic memory allocation. If you do the same thing in C, it'll assign really a pointer. It doesn't allocate new memory for the assigned variable. But here we actually allocate memory for the array all, and then copy the whole content of numbers array into the all array. This is done behind your back, so you don't have to do memory allocation. Another list is built for pi B gates, and you have a group as num, which is 2, 17, num plus 1, which is 3. So it's another array. So if a scalar value is assigned to an array variable, it becomes a single element list automatically. So a equals to 4, then because a has an @ in front of it, it's not a scalar, so it actually gets parentheses 4 as a list with a single element. If you have $a equal 4, then it'll be a scalar assignment. We'll take a 10-minute break and come back at 2. Okay, so let's start up again. So, array variables are preceded with the @ sign, indicating it contains a list. A $sign indicates a scalar variable containing a single element. So, if you assign a single element to an array variable, then it is converted into a list with a single element. Converted into a parentheses 4. If you assign 4 to a @a, then @a gets a parentheses 4. You can insert array elements into lists, so you have an array of 6, 7, 8, and you can assign numbers, insert it into 1, 2, and 10. So insert 6, 7, 8 into 1, 2, and 10 to get 1, 2, 6, 7, 8, 10. And you can add a 0 in front of it by doing this, 0, comma, 1, 2, 6, 7, 8, 10. You can add a 99 at the end of it by doing this. Add numbers, comma, 99, assigned to numbers. So the inserted array elements are at the same level as the other elements, not a sublist, as lists in PRR are flat. It's not hierarchical. Now, if you do these insertions, the resulting array is flat. You cannot tell how it's constructed. It's a flat list of numbers. If a list only contains variables, then you can use it to the left on the left side of an assignment. So this guy assigns 1, 2, 3 to A, B, C. So A gets 1. It's assigned in order. A gets 1, B gets 2, and C gets 3. This guy swaps A and B. By assigning BA to AB, A gets B's value, and B gets A's value. So this is a nice trick you cannot do in C++, right? If you want to swap two values, even in shell scripts and C++, you must have a temporary variable, assign A to a temp, assign B to A, assign temp to B, right? But here you can do this direct swap. So this guy assigns A to D and BC to Bill. So you grab the first first element assigned to the scalar variable $D, and grab the rest of the list assigned to the array variable @Bill. So this guy, on the left side you have a scalar variable $E and followed by an array variable $Bill. On the right hand side you have a list, array variable. Now the effect is to grab the first element of Bill, place it in E. So what does Bill have? Bill has BC. So the effect of this is, so E and C, you place B in E, so B has 1, so E gets 1, and place C in Bill, so Bill is a single, the array is a single element 3. So let's trace through these values. So initially, ABC gets 1, 2, 3. After this swap, ABC is now 2, 1, 3 because it swapped A and B. After this assignment, then ABC is still 2, 1, 3. Now D is equal to 2. E is 2. Bill has 1, 3. After this assignment, E gets 1, first element of Bill, and new Bill gets a single element of 3. Right? So an array variable can only occur in the last position in the list because it's greedy and consumes all the remaining values. So that is, if you have a list like this, then you must have a bunch, one or more, 0 or more dollar scalar variables followed by a single list variable. Otherwise, you have ambiguities as to how long each list is. By having this, you can assign the scalar variables by grabbing the first few elements and assign the remaining elements into the last array variable. So array variable is assigned to a scalar then the number assigned is the length of the array. So nums is 1, 2, 3. It's length is 3. So if you do $n equals add nums, then n gets 3. The size, the length of the array. Context determines whether the length of the array is used for the list. So this guy, n gets 3. If you assign the array to a single element list, then it's a list-to-list assignment. So you grab the first element of nums and assign it to the first element of the list on the left, which is n. So n gets 1 in the second case. First assignment is a scalar assignment. So nums is treated as a scalar, returning its length. Second assignment is array assignment. So you grab the first element of nums and silently discarding the rest. So in the previous examples, you had a scalar variable followed by an array variable. So the array variable at the second position will gets the rest of the array on the right. But here you only have a single scalar variable, so you only get the first element, and the rest is thrown away. So each element of an array can be accessed by its integer position. First position starts at 0. So you can access it as $A0. Notice that the @ sign on the array name becomes $1 when you assign individual elements. This indicates that after the you do a subscripting, you use subscripting, you get a scalar variable back. It's no longer an array. So array A is Bill Gates' PyTorch quote word, as we discussed before. It constructs a list of single words. Name 1 is a scalar variable, gets assigned the 0th element, which is Bill. So 0, 1, 2, 3, these are the indexes. Name 2 gets assigned to the third element, which is toss. And you can use it on the left-hand side also. You can do assign Clinton to the first element, which is Gates. We replace Gates with Clinton. So now the at A array becomes Bill Clinton PyTorch. You can use all the usual scalar operations, and so you can do ++. Then it modifies the first element, the 0th element, into a 2 to get 2, 2, 3 from 1, 2, 3. You can do a + = 4 on the first element. So now it's 2, 6, 3. Second, the 2 gets added 4, and the second element added to the first element. So now it's 3 + 2 = 5. So we can swap first two elements. So the array now is 6 to 5. Accessing a list of elements from the same array is called a slice. So this is an array, and this is a slice. Notice that you have the square brackets and at in front of the name. It means that after you take the slice, you still get an array back. It's a different array. So A10 is this array with content 2, 1. To assign it to A01, so it's an array-to-array assignment. Then the variable, array variable A now gets turned into 2, 1, 3. after this assignment. You swap the first two elements. So you can achieve the same effect by the percent dollar A0 A1 equals percent dollar A1 A0. So the slice notation is more concise. So this guy assigns the second element, that is 1, the first element if it comes from 0, so which is equal to 1, and make all the three elements like the second. So now the A is now turned into 1, 1, 1. You take the 1 and assign it to all three. And finally, you assign 7 and 4 to the last two elements of A, so you get 1, 7, 4. So notice slices use at rather than dollar is because slices work with lists rather than scalar values. While in the array subscripting, if you use dollar, we will have a single. We are accessing a single element of the array. So you can also work directly on lists. So C equals this list. You pick out the second element, which is 3. Assign it to the scalar variable C. So set C to 3. So this guy picks out 2 and 4, which is this element and this element. 0, 1, 2, 3, 4. And assign it to an array B. So now array B contains 3 and 5. So it's equivalent to if you assign the list to an array variable first, and then do the slice. Or you can use the list directly in the slice, like this one. So if you you can also assign, say the if you pick out a single element of the array of the list, assign it to a slice, say FC, then C gets becomes a single becomes a list with a single element of parentheses 3. So, but you cannot do the reverse. That is, you cannot assign a this guy 2, 4 to a scalar variable. So you can use expressions for the subscripts just like in C++. The list 1 is 5, 6, 7. $n is a scalar value 2. $m is list 1. $n, which means that pick out the second element, which is 7. Assign it to the scalar variable m. $n minus 1. Assign it to p, which is the first element, 6. So p gets 6. So this guy means that you pick out the first element, which is 6, and assign it to a list. So now, on the left-hand side, you have a list with a single element 6. So you can also assign it to a slice, say add p, then add p gets the list with a single element. So you can use array expressions as to index slices. So here's one array nums 567 and another array 210. So if you do this, it means that replace this at I with the list 210 before doing the subscripting. So you really take the slice. So this is the zeros, this is ones, this is the second. So if you do 210, it means that pick out the elements in the order 7, 6, 5, and assign to REV, reverse. So REV now gets 765. So this is same as nums 210. It's a slice, then it turns into the reverse of the original array. If you access an array beyond the end of the array, so this is the 567 3-element array. So you assign the third element a value bill. Notice that it starts from 0, so 0, 1, 2. There is no third element. So curl allows you to do this, except if you access an array beyond the end, it returns undefined value. So which is 0 when used as a number, empty string when used as a string. So here sum 3 is 0 for empty string. You assign bill to it, overwrite it. Now you get a 4-element array back, 567 bill. And you assign 5 to G dot, then you get bill and 5th element of G dot, and this guy is undef. That is because nums 4 is never assigned, so it's undef. So here you see that Perl is very permissive, while in C, if you make the same mistake, it will give you a fatal error if you access an array beyond its end of the subscript. While Perl silently allocates memory behind your back and allows you to do this. So assignment to an array element with a subscript less than 0 is a fatal error. So if you say nums minus 1, then it gives you a fatal error. So $pound bill gets the index value of the last element of bill. So here, bill is this single word array, a list of single words: cheap, rich, lucky, likes pie. And $pound returns 3. So indexes are 0, 1, 2, 3. So it returns the last, returns the index of the last element, which is the number of elements minus 1. Accessing an array with a negative subscript comes back from the end. So that is, if you access, okay, so if you print bill $pound, it prints out bill square brackets 3, which is the likes pie. Here's the print out bill minus 1 is the next to the last element, which is lucky. Here's the print bill minus 1. Minus 1 comes back from the end. That is, likes pie is really also the minus 1th element. It prints out likes pie. Minus 2 is the next to last element. Minus 3 is this element. Minus 4. So minus 2 is lucky. Minus 3 is rich. So notice that you can use the negative subscript when you are reading the element, but when you assign a value to a negative subscript entry, it will give you a fatal error, as we discussed in the last slide. If you assign it to an array element with a subscript less than 0 is a fatal error, but you can access it, counting back from the end. Notice that the last one is -1. While the first element, counting from forward, starts from 0. Push and pop to add and remove values from the end of the array. A is an array with 3 elements, 1, 2, 3. New is a scalar with value 6. You push, you get same as this assignment. So you append 6 to the end of the A list, 1, 2, 3, 6. You pop, you remove the last element of A so far, that is, you delete 6. Now O value gets 6, and now A gets 1, 2, 3. You can push multiple values to get 1, 2, 3, 4, 5, 6 if you push A, 4, 5, 6. So if you pop empty array, it gets undefined. So shift and unshift add and remove values from the beginning of the array. That is from the left end of the array. So A equals 1, 2, 3, new is 6. Unshift, it means that move all the elements of A to the right by 1 position and place new at the leftmost position. You get 6, 1, 2, 3. You shift, assign to old, then old gets 6, the first element, and A gets the rest, 1, 2, 3. You do unshift, that is move the element to the right, and place the 4, 5, 6 to the left of the array. So you get 4, 5, 6, 1, 2, 3. So we saw shift and unshift before in the shell scripting, right? If you recall, we discussed this command line argument. So in the shell script, if you say shift, it means that shift everything to the left by 1 position and assign $1 to $0, $2 to $1, and throw away $0, right? So here it's the same. Here, always remember shift, move stuff to the left. Unshift, move stuff to the right. And how many positions you shift or unshift depends on how many values you have. So here you have unshift A, 4, 5, 6. It means that shift A to the right by 3 positions and place 4, 5, 6 to their left. If you say shift A new, then you shift it by 1 position and place 6 to the left of A. So it depends on how many elements you have. You shift how many positions. Reverses the array. So A is 1, 2, 3. You reverse it. You get 3, 2, 1. Notice that it returns a reversed array, but the original array is not modified. So at A is still 1, 2, 3. Same thing if you do this, reverse 1, 2, 3, assign to B, or you can reverse it and assign it to the same variable. Now B gets assigned 1, 2, 3. That is 3 to 1 reversed. Again, you get back 1, 2, 3. So sort returns a sorted array in ascending order, ascending ASCII order. So this guy, size, is an array of single words, small, medium, and large. If you sort it, it returns a sorted array in ASCII order. That is large, medium, and small, because L comes before M and comes before S in the ASCII order. So sort size now contains a list large, medium, and small. Size still contains the same original list. So this guy is the same effect. You can place this list directly into this sort argument instead of assigning to a array variable first. So this guy is a list of numbers 1, 2, 4, 8, 16. If you sort it, assign it to B, then B contains 1, 16, 2, 32, 4, 6, 64, 8. Because a sort doesn't know about numbers. It only knows about the ASCII values. Therefore, it thinks 1 is before 2. Therefore, anything that starts with a 1 must come before anything that starts with a 2. So 1 followed by 16, followed by 2, etc. The 1 comes before 16 because 1 can be viewed as 1 followed by a null string. So 1, 6 is obviously comes after 1 null. So array variable interpolation, just like we discussed before for scalar variable. So here, Comp111 is this list of words, Unix, shell, and Perl. You say print $Comp111 0. It means that pick out the first element, 0th element of Comp111. Unix programming is mainly done in Perl. That is the second element of the list. And you can do assign n to 3 and say subscript $n minus 1, same as same as 2. So it takes out the Perl. So you can print out an array directly or a slice. So you say add A and print double quote. So then you print out 1 space 2 space fill space 3. So it's interpolated with spaces between the elements. Or you can pick out 1 and 2 as a slice, which is 2 and bill, and print it out with a space in the middle. So if an operator or function returns, expects a scalar argument, the argument is evaluated in a scalar context. So $n gets assigned value at nums. So $n gets the length of nums. I think we discussed this already, but this is just to reiterate this point. So if you assign it to a list, parentheses $n is a list with a single element. That is, this operator or function that assigns to operator expects a list argument. Then the argument is evaluated in the list context. So now n gets the first element of nums. So that is, if you look at just to the right of the assigns tool, you can see they're the same, right? Both are take at nums array and assign it to something else. But how you treat this assignment, how you treat at nums is dependent on what you assign it to. If you assign it to a scalar variable, that is, this assigns operators expect a scalar argument. Argument is the at nums. You can view equals, this equal sign as a function or operator that expects an argument. Then depending on how it's used, what's on the left of the assignment, you evaluate it in either a scalar context or a list context. A scalar value used within the list context is promoted to a single element array. So this guy says assign a scalar value 1 to an array variable nums. Then nums gets becomes a single element array parentheses 1. So this guy count is a comment. So this is just saying that, okay, treat the rest of the line as a comment. So just a review, add refers to the entire array or slice of an array when used with the square brackets. $sign refers to one element of the array always used with the square brackets. So Perl is quite permissive. That is, you can't assign a single element to an array and it gets converted into an array with a single element. Like we did before. You assign 1 to an array, then it gets a single element array. So array chomp also works by removing any ending new lines in each element. So now Comp111 equals Unix new line, shell new line. Per, if you say chomp, it chomps off the new line to get this guy. So you wouldn't deliberately type in the new line when you write it like this, but if you grab the words from the stdin standard input, then if you forget to chomp it, when you enter the input, you can chomp it here after you construct the list. So notice that chomp actually modifies its argument, right? If you recall, in the previous reverse and sort, it keeps the argument the same, but returns a different list. Here, reverse A is the same, but B gets assigned a reversed list. But here, chomp actually modifies the Comp111 list. So chomp is especially useful when reading a file or input from a user. So you can assign stdin to an array. It'll return all remaining lines up to the end of the file if you do I/O redirection. Right? If you recall, you can use the less than sign to redirect the input from stdin into a file. Read from a file instead of from the stdin. Or you can type in the input from the keyboard if you do not do redirection. So if you do this, then you if the I/O is not redirected, then you just type in many lines, and finally type in Control D, indicating end of input. If you do I/O redirection and replace the SCD with a file, then it'll read until the end of the file. Notice that if you assign it to a scalar, then you can use the new line to terminate the input. But here, if you assign it to an array, then you must use Control D because it expects multiple lines. So new line is not the end of the input. So after you read all the lines, you do a chunk and it removes all the trailing new lines from all the lines. So here's an example of how to find the biggest value. So at A is this array, a list of values. You say max is equal to the first element, that is 23, and you iterate over all the elements, and if the element value is greater than max, you assign max to be the element. So finally, the max contains the maximum entry of the list. So what is add A? Add A is this array variable, but it's used in the scalar context. So it returns the size of the list, which is 6. So you can see that this for loop iterates from 1 to 5, which is correct, right? Because you have the 0th element assigned to max already. So you iterate over the 1, 2, 3, 4, 5. So right? Any questions on this? So if you did $i less than equal to A at A, it will be wrong. It'll index beyond the end and gets you an undef, which perhaps doesn't matter in here because you're taking a max, but it does matter if you're taking a min. Because undef is treated as a 0. Oh, okay. So everything's fine. Not going too fast, am I? So who thinks I'm going too fast? You? Who else? So you can catch up, right? It's not too difficult. Okay, good. See you next time.